Divide each and every element by 5 by 3 because 5 by 3 is the key element. 2, 0, 2, 0, 5 by 3. Sign less than or equal to, then we are going to convert the equation by adding a slack variables S1 and S2. This is very important. So 4 minus 4 is 0. 3 minus 4 by 3. Here 3 is the LCM. 3 3s are 9 minus 4. 9 minus 4 is 5 by 3. Hello dear students, welcome to this session of OR class, Operation Research class. I am Mr. Niranjan, faculty, Department of Computer Science, Vidhyaashram, first grade college, the Temple of Excellence. Now in this session I am going to discuss regarding solving a problem, linear programming problem by Big M method. Now let us come to the steps. Big M method, how to solve a linear programming problem using the Big M method by constructing the simple initial table, that is simple algorithm. Now, how to solve this linear programming problem using Big M method? Now, the Big M method extends the power of simplex algorithm to problems that contains greater than constraints. So, the Big M method extends the power of simplex algorithm to the problems which contains greater than constraints, the constraint which contains greater than or equal to. Now it does so by associating the constraint with large negative constants which not part of any optimal solution if it exists. Now in the simplex method only those LP problems were where the constraints had less than or equal to sign were only considered. So here we are going to consider the constraint which have the inequality less than or equal to. But in Big M method, LPP having constraint with any inequalities like less than or equal to, greater than or equal to, or equal to. See, in the simplex method, only those LPP problems we are going to solve which contains the constraints less than or equal to. Whereas in Big M method, we can solve the problems of LPP which contains the constraints, inequalities less than or equal to, greater than or equal to, or equal to. So depending upon less than or equal to, greater than or equal to, and equal to, we are going to add the variables like slack variables, surplus variables, and artificial variable in case of Big M method. Now let us come to this first step. What is this? In Big M method also the problems has to be first brought into the standard format where the objective function has to be maximization. First point to be noted in this Big M method is the objective function is of the form maximization. Suppose if it is minimization, it has to convert it into the maximization form. So first point is the function to solve this using Big M method. The function must be, the given equation must be an maximization type. The objective function is of maximization type. Suppose if the objective function is of minimization type, then it should have to be converted. It can be converted into maximization. Now how to convert? But I will explain. So just by multiplying the objective function by a negative sign, the minimization will be converted into the maximization type. Now all the inequalities have to be converted into the equation. All the inequalities should be converted into the equation. Now the RHS of all constants should be non-negative. The right hand side of all constraints should be non-negative. Then the constraints or inequalities with a sign less than or equal to can be converted into the equation by adding a slack variables like S1 and S2. So S1 and S2 are the slack variables which can be added if an inequality is of the form less than or equal to. So the constraints or inequalities with sign less than or equal to, then we are going to convert the equation by adding a slack variables S1 and S2. This is very important. So for less than or equal to, we are going to add a slack variable S1 and S2. That I will explain while constructing the simplex method. Now the constraints or inequalities with a sign greater than or equal to can be converted into equation by subtracting the surplus variable S1 and S2. See, if it is less than or equal to, we are going to add here adding a slack variable. We are going to add a slack variable here plus plus S1 and S2. In case of the inequality greater than or equal to, if it is greater than, then we are going to convert by subtracting a slack variable. So this is very important concept. So here we are going to subtract S1 and S2. So if it is less than, just add. If it is greater than, subtract. That's all. So surplus variables. Here we are going to subtract the surplus variable. We are going to add here the slack variables. Now, and also the same time by adding the artificial variables A1 and A2. This is very important point. So if it is less than or equal to, then we are going to add the slack variable S1 and S2. If the inequality is of the form greater than or equal to, we are going to subtract the surplus variable, and also at the same time we are going to add the artificial variables like A1 and A2. Okay. Now let us come to the next. So in general, artificial variable is a non-negative variable added to the left hand side of each constraints of either greater than or equal to type in a linear programming problem. So what is this artificial variable? So artificial variable is a non-negative variable. It's a non-negative variable added to the left hand side of each constraints of either the inequality greater than or equal to type in a linear process. So for an inequality which is of the form greater than or equal to, we are going to add a non-negative variable on the left hand side of the constraints, that is called a artificial variable. Now the purpose of the artificial variable is to help in getting an acceptable, that is non-negative initial basic feasible solution of the LPP. To get the acceptable, that is non-negative initial basic feasible solution to the linear programming problem, which is not possible without obtaining the artificial variable. So without having an artificial variable, we cannot get the non-negative basic feasible solution, BFS, basic feasible solution. So therefore we are going to use an artificial variables. Now the slack variables are added on the left hand sides of the equation of the type less than or equal to, and the surplus variables are added to the LHS of the type greater than or equal to type constant. So there is no need for either slack or surplus variable or equal to constant. However, the artificial variable is introduced on the left hand side of each equal to type of a constant. So these are the few points which are to be noted. Now the procedure, step-by-step procedure to solve a big M method, or it is also called as a penalty method. Now if the problem is of minimization, convert it into maximization by multiplying the objective function by minus sign. Just multiply by negative sign, multiply by -1 to convert the minimization into maximization. So if the given objective function is of minimization type, convert that minimization objective function into maximization type by multiplying the objective function by negative sign, that is by -1. So by multiplying throughout the equation objective function by -1, that will converts to minimum, will converts to maximization. So minimum is converted into max z by multiplying -1. Now if any of the constraints in the right hand side RHS coefficient is negative, if the negative coefficient, mark it as positive by multiplying both sides of the constant by negative sign. So if any constraints on right hand side, if any constraints on right hand side are negative, if any constraints on the right hand side are negative, then make it positive, just make it positive by multiplying throughout the equation by negative sign. So this will of course change the inequality sign, that is less than will be converted to the greater than or equal to, or greater than or equal to will be converted into less than or equal to. So if the right hand side of any inequality is negative, just convert it into positive by multiplying throughout by negative sign, and the inequality will changes to, if it is greater than or equal to, will reduces to less than or equal to. If it is of the form less than or equal to, then it will converts to greater than or equal to. Now, if the constraints introduced in the constraint introduce slack, surplus and artificial variables on the left hand side to convert the constraint into inequalities. So, we are going to introduce the slack variables, surplus variables as well as the artificial variables on left hand side of the equation to convert the constraints into equalities. Now, if the constraint is of the type, as I explained just now, if the constraint is of the form less than or equal to, add a slack variable. Just constraint less than or equal to, we are going to add a slack variable S1 and S2 on the left hand side. So, if the constraint is of greater than or equal to, subtract the surplus variable S1 and S2 and add the artificial variable S1 and S2 and add the artificial variables A1 and A2 on the left hand side. So, if the constraint is of the form greater than or equal to, subtract a surplus variable S1 and S2 and an odd artificial variable A1 and A2. If the constraint is of the form equal to, if it is equal to, add only the artificial variable on the left hand side. Okay. So, these are the things. If it is greater than or equal to, less than or equal to and equal to, we have to use S1, S2, A1, A2 depending upon the given condition. Now, next, these are the few steps which are involved in solving the Big A method. Then construct the initial simplex table and follow the procedure as like the simplex method and get the solution. That's it. These are the few steps which are to be followed to solve a LPP using Big M method. Now, let us take an example. Now, solve by Big M method. Max Z is equal to minus 2x1 minus x2 subjected to 3x1 plus x2 constraints is equal to 3 and 4x1 plus 3x2 is greater than or equal to 6, x1 plus 2x2 is less than or equal to 4. So, this is the problem. So, we have to solve this using Big M method. Now, listen to me. So, as we know, if the inequalities are equal to, greater than or equal to, less than or equal to, what are the things we are going to add? Suppose if it is equal to, if the inequality is equal to, we are going to add an artificial variable. So, let us add an artificial variable. So, the first equation will reduce us to 3x1 plus x2 plus a1 is equal to 3. This is the first equation. Now, what is the second equation? Greater than or equal to. So, for greater than or equal to, we are going to subtract one surplus variable and add an artificial variable. Okay. So, for greater than or equal to inequality, we are going to subtract a surplus variable and we are going to add an artificial variable. Okay. So, therefore, this equation will reduce us to 4x1 plus 3x2 minus s1 plus a2 is equal to 6. Right. Now, for the third equation, x1 plus x2 is less than or equal to 4. For less than or equal to inequality, we are going to add a slack variable. That is a x1 plus 2x2 plus s2 is equal to 4. So, these are the first step we are going to follow in this Big M method. So, for less than or equal to, we are going to add a slack variable. For greater than or equal to, we are going to subtract one surplus variable and add an artificial variable, and for equal to, we are going to add one artificial variable. So, the given equation reduces to 3x1 plus x2 plus a1 is equal to 3, 4x1 plus 3x2 minus s1 plus a2 is equal to 6 and x1 plus 2x2 plus s2 is equal to 4. These are the constraints. Now, what about the max z? So, maximum of z can be written as this is minus 2x1 minus x2 plus 0 s1 plus 0 s2 minus m into a1 minus m into a2. This is the reduced equation. So, therefore, the equation can be written as introducing the slack variables, surplus variable and artificial variable to the constraints. The given equation can be written as max z is equal to minus 2x1 minus x2 plus 0 s1 plus 0 s2 minus ma1 into minus ma2. Initial cost of s1 and s2 are 0, a1 and a2 coefficients are minus Big M. That is why this is called a Big M, minus M, Big M method. Now, subjected to the constraints 3x1 plus x2 plus a1 is equal to 3 and 4x1 plus 3x2 minus s2 plus a2 is equal to 6 and x1 plus 2x2 plus s2 is equal to 4, where x1, x2, s1, s2, a1, a2 are all greater than or equal to 0. S1 is the slack surplus variable, s2 is the slack variable and a1 and a2 are the artificial variables. By knowing this, let us come to the initial simplex table. Now, as usual, like in the previous problems, we did the construction of initial simplex table. The same procedure we are going to follow. Now, before that, let us write down the initial vectors. Now, write down the coefficients for the constants. Here, the coefficients of x1, x2, then x1, x2, s1, s2, a1, a2 and x0. Now, let us come to the first equation. The coefficients are 3, x2 is 1, s1 is not there, s2 is also not there, a1 is 1, a2 is equal to 0. Now, and the value of x0 is 3. Now, for the second equation, coefficient of x1 is 4, x2 is 3, s1 is minus 1, s2 is not there, 0, a1 is also 0, a2 is 1. Okay, this is 0. Now, and the constant is 6, x0. For the third equation, coefficient of x1 is 1, x2 is 2, s1 is 0, s2 is 1, then a1 is 0, a2 is also not there. And the constant x0 value is equal to 4. Now, just observe carefully, this 0, 1, 0, 0, 0, 1, 1, 0, 0, this will form an identity matrix. This is an identity matrix of order 3 rows and 3 columns. So, 1, 0, 0, 0, 1, 0, 0, 0, 1 forms an identity matrix with the values S2, A1 and A2. Now let us come to the initial simplex table. So, in the initial simplex table, we are going to use these variables A1, A2, S2 along with this. So, that is the initial simplex table, we are going to use A1, A2 and S2 because A1, A2 and S2 will form an identity matrix and the coefficients for this A1, A2 and S2. A1, A2 and S2, coefficient of A1 from the initial is minus M1, minus M2 and for S2 it is 0. Write down the coefficients of S2 0, M minus M for A1, minus M for A2. So, that is A1 minus M, A2 minus M, S2 0 and Zj, delta J is equal to Zj minus Cj. And the coefficients of basic variables x0, x1, x2, x1, s2, a1, a2 and the ratios. The coefficients of the basic variables, first for the objective function, the coefficients are x1. x1 is equal to minus 2, x1 is minus 1, s1 is 0, s2 is 0, m1, a1 is minus m and minus m. So, here minus 2, minus 1, 0, 0, minus m and minus m for a1 and a2. Write down the values of the first here. So, for the first equation what we have 3, 1, 0 and this 3. It will start with the x0 is 3. I will write straight away 3, 3, 1, 0, 0, 0, 0, 1, 0. Okay. Now, similarly, for the second line, we are going to use the same value 6, 4, 3, 6, 4, 3, then minus 1, 0, minus 1, 0, again 0, 1, 0, 1. For the next third line, 4, 1, 2, 4, 1, 2, then 0, 1, 0, 1, 0, 0. So, these are the values of coefficients of x0, x1, x2, s1, s2, a1, a2 from the three conditions, three equations given, that is subjected to the constraints, the three constraints. Find out the value of Zj, then delta J. So, Zj is equal to multiply these and add minus m into 3 plus minus m into 6 plus 0 into 4. So, minus 3 into m is minus 3m, minus into plus minus m into 6 is minus 6m. This is equal to minus 9m. First value is minus 9 times m. Next, second, this minus m into 3 is minus 3m, minus 4 into m is minus 4m. This is equal to minus 7m. So this is minus 7 times m. Next, minus m into 1 is minus m. Minus m into 3 is minus 3m. This is minus 4 times m. Minus 4m. Okay. Minus m into 0, 0. Minus into minus plus m plus 0 is m, capital M. Next. Here, minus m into 0, 0, minus m into 0, 0, 0 into 1 is 0. This is totally 0. Again, minus m into 1 is minus m, plus 0 is minus m. Minus m into 0, 0, minus m into 1 is minus m, plus 0 is minus m. So, these are the values of Zj. Now, find out delta j. Delta j is equal to Zj minus Cj. Now, Zj is minus 7 minus 2, minus 7 minus 2. Minus 7 minus 7m minus 7m minus 2, minus into minus, it becomes plus. So, this can be written as minus 7m plus 2, or you can also write 2 minus 7m. Similarly, this can be written as minus 4m minus 4m minus 4m minus of minus 1 is minus 4m plus 1. This can be written as 1 minus 4m. So, 1 minus 4m. Okay. Next, m minus 0 is m. 0 minus 0 is 0. Minus here, minus m minus of minus. Minus m minus of minus m. Minus m minus into minus plus, this is equal to 0. Similarly, minus m minus of minus m is plus 0. So, these are the values of delta j. Now, in delta j, just in this row, just identify the least negative m value. Here, this is the values of delta j. So, here just identify the least negative m here. So, here least negative m is minus 7m. 2 minus 7m is the least negative m. So, therefore, this is called the incoming variable. This is the incoming variable. This is the incoming variable. So, here x1 is the incoming variable. Let us mark this. After this, find out the ratios. How to find the ratios? The ratios are nothing but ratios is equal to here x0 divided by the incoming variables. X0 divided by incoming variables are x1. So, x0 divided by x1. x0 is 3, x1 is 3. 3 divided by 3, this is equal to 1. x0 by x1, 3 by 3 is 1. Next, second value x0 is 6 divided by 4. 6 divided by 4 is nothing but 3 by 2 means 1.5. Next, 4 divided by 1. This is equal to 4. Now, identify the least positive value here. Now, what is the least positive value in 1, 1.5 and 4? The least positive value is 1. So, therefore, this is the outgoing variable. So, therefore, just mark this. This is the outgoing variable. Okay. So, the incoming is x1, outgoing is a1. So, a1 is the outgoing variable. Now, what is the key element? Key element is nothing but the intersection of incoming variable and outgoing variable. That is the intersection of incoming column and the outgoing row. The intersection of row and column of incoming and outgoing variable is the key element. This is the key element. So, key element is equal to 3. Here 3 is the key element. Now, in the next initials table, we will do for the first iteration. Let us go for the first iteration. In the first iteration table, what we are going to convert is, convert this key element as 1. Now, convert this key element as 1 by dividing the entire row by 3. So, if you divide R1 by 3, you will get new row, that is called R1 dash. R1 dash is equal to R1 divided by 3. And the next step is convert this element 4 as 0 and again this element 1 as a 0 by using the elementary row operation. That's it. Now, what is the next step? Convert 3 as 1 and the 4 as 0 and 1 as 0 by using the elementary row operation. That's it. Now, let us go to the next table, that is iteration number 1. In the iteration number 1, so here convert this element 3 as 1 and the remaining elements 4 and 1 as 0 by using the elementary row operation. Now, let us convert this 3 as 1. For converting this 3 as 1, divide the entire row by 3. Now, here R1 dash is equal to R1 divided by 3. So, what are the elements of R1? R1 contains 3, 3, 1, 0, 3, 3, 1, 0, 0, 1, 0, 0, 1, 0. Divide each and every element by 3. So, what you will get? So, you are going to get it as, this is equal to 3 by 3 is 1, 3 by 3 is 1, 1 by 3, again 0 by 3 is 0, 0 by 3 is 0, 1 by 3 and 0. So, substitute these values in the first iteration table. So, here 1, 1, 1, 1, 1 by 3, 0, again 0, 1 by 3 and 0. Okay, right. Now, next one is convert this element as 0 by using the elementary row operation. Okay. Now, for this, here this is 4. So, this 4, just subtract by 4, you will get the answer. Now, R2 dash is equal to R2 minus 4R1. That's it. R2, what are the elements of R2? R2 contains 6, 4, 3, 6, 4, 3, 6, 4, 3, minus 1, 0, 0, 1, minus 1, 0, 0, 1, minus, multiply by 4 times R1. So, what is R1? These are the elements of R1. For this, just multiply by 4. If you multiply by 4, what you will get? 4 into 1 is 4, 4 into 1 is 4, 4 by 3, again 4 into 0, 0, 4 into 0, 0, 4 by 3 and 4 into 0 is 0. Subtract this. So, if you subtract, what you will get? 6 minus 4 is 2, 4 minus 4 is 0, 3 minus 4 by 3. Here 3 is the LCM, 3 3s are 9 minus 4. 9 minus 4 is 5 by 3. Minus 1 minus 0 is minus 1, 0, 0 minus 4 by 3 is minus 4 by 3 and 1. Substitute these values for R2 dash. That's it. So, in the table, I am going to substitute these values as 1 minus 4 by 3, then 0, then minus 1, 5 by 3, then 0 and 2. This is regarding R2 dash is concerned. Okay. R1 dash, we got R1 is equal to R1 divided by 3. So, the elements are 1, 1, 1 by 3, 0, 0, 1 by 3 and 1. The elements are 1, 1, 1 by 3, 0, 0, 1 by 3 and 0. Now, similarly for R2 dash is equal to R2 minus 4R1. So, we are going to get these elements 2, 0, 5 by 3, minus 1, 0, minus 4 by 3 and 1. So, that is, what is the values you are going to get? 2, 0, 5 by 3, minus 1, 0, minus 4 by 3 and 1. Okay. Now to find out R3 dash, now write down R3 dash is equal to R3 minus R1. So, the elements of R3, we have to take the elements of R3 from the previous table and subtract with. So, the elements are 4, 1, 2 from the previous table, 0, 1, 0, 0. R1 dash is equal to, the elements are 1, 1, 1 by 3, then 0, 0, 1 by 3 and 0. Subtract this. 4 minus 1 is 3, 1 minus 1 0, 2 minus 1 by 3. 3 to the 6 minus 1 is 5 by 3, 0, 1, minus 1 by 3 and 0. Substitute these values. So, that is 3, 0, 5 by 3, then 0, 1, 0, 1, minus 1 by 3 and 0. So, these are the values. Now, since A1 is the outgoing variable, if we want, we can cancel this. Now, find out the value of delta J. What is delta J? Multiply this. Minus 2 into m is minus 2m, minus 2m is minus 4m. minus 2 into 1 is minus 2, minus 2 into m is 2m. So, minus 2m. Next, minus 2 into 1 is minus 2, minus 0 is minus 2. Minus 2 into 1 by 3 is minus 2 by 3. Minus m into this is minus 5m divided by 3. So, this is equal to, take LCM. If you take LCM, 3 is LCM, minus 2 minus 5m. So, this is minus 2 minus 5m divided by 3. Minus 2 into 0 is 0, minus into minus plus m. So, 0 into 2 is 0, 0 and 0. This is not required. 0 minus m and 0. Now, find out the value of delta j minus cj, that is zj. Zj is equal to, subtract. Minus 2 minus of minus. Minus 2 minus into minus plus 2, that's equal to, this is 0. If you subtract this, minus 2, see here, minus 2 minus 5m by 3, minus of minus 1 is plus 1. Take LCM, 3 is LCM, minus 2 minus 5m minus into minus plus 3, 3 minus 2 is 1 minus 5m by 3. So, this is 1 minus 5m divided by 3. Now, m minus 0 is m, 0 minus 0 is 0, this is m. Again, this is not required. Minus m, minus m, minus m, minus of minus is plus m, gets cancelled, 0. Now, identify incoming and outgoing variable. Here, the most negative m values are 1 minus 5. So, the least m value is minus 5m. So, this is the incoming variable. This is the incoming variable. So, these are the incoming values. Now, find out the ratio. What is the ratio? Ratio is equal to x0 divided by incoming variables x2. So, what are the values here? So, x0 is 1 divided by x2 is 1 by 3. This is nothing but 3 by 1 into 1 is 3. First value is 3. Second, x0 is 2 divided by 5 by 3. That's equal to 6 by 5. 6 by 5 means 5 ones are 5, 10, 5 twos are 10. 1.2. Next, x0 is 3 divided by 5 by 3. 3 divided by 5 by 3. That is equal to 9 by 5 is nothing but 1.8. So, this is 3 and this is 1.8. Now, identify the least positive value here. The least positive is 1.2. So, these are the outgoing variable. Outgoing variable. So, this is the outgoing variable. So, these are the outgoing variables. So, here x2 is the incoming, a2 is the outgoing variable. Identify the key value. Key element here is the intersection of the row and column is 5 by 3. So, the key element is equal to 5 by 3. So, in the next iteration, since here if delta j is greater than or equal to 0, optimality is reached. Here this is not greater than or equal to 0. So, again we have to go for the one more iteration. Here, so in the next iteration table, just replace a2 by x2. a2 is the outgoing variable, x2 is the incoming variable, then this will become x1 and this is not a, this is s2. This a2 is replaced by x2 and s2 will remain the same as it is. Okay, I will go to the next iteration table. Now, next in the next iteration table, convert this 5 by 3 as 1. So, to convert 5 by 3 as 1, divide the entire row by 5 by 3, the key element. So, what are the elements? 2, 0. Now, R2 dash is equal to R2 divided by 5 by 3. What are the elements of R2? 2, 0, 2, 0, 5 by 3, 2, 0, 5 by 3, minus 1, 0. Minus 1, 0. Because a1 and a2 are the outgoing variable, we can cancel. Now, if we divide by 5 by 3, divide each and every element by 5 by 3, what you are going to get? See, The values are 3 2s are 6 by 5. First element is 6 by 5. This is 0. And the second element gets cancelled 1. This goes to the numerator, minus 3 by 5 and 0. Okay. So that's I am going to write in the next table for R2 dash. R2 dash is equal to, what are the elements? 6 by 5, 6 by 5, 0 1, 0 1, minus 3 by 5, minus 3 by 5 and 0. These two are deleted. Okay. Now let us convert this 1 by 3 as 0 and 5 by 3 as 0. For this we are going to use the operation. Let us write down R1 dash is equal to, R1 dash is equal to, what are the elements we have here? 1 by 3. So here we have, what are the elements in R2 we have? Here it is 1. So therefore we can write the operation as, so we can write R1 dash is equal to R1 minus 1 by 3 R2. So R1 dash is equal to R1 minus 1 by 2, 1 by 3 times R2 dash. So write down R1 first. What are the elements in R1? We have 1 1, 1 comma 1, 1 by 3 0, 1 1, 1 by 3 0, 0. Okay. Now R2 dash, these are the elements we have in R2 dash, that is 6 by 5 comma 0 comma 1 comma minus 3 by 5 comma 0. For this just multiply by 1 by 3. So if you multiply by 1 by 3, what you will get? 1 comma 1, 1 by 3, 0 0, 3 2s gets cancelled, you will get 2 by 5, 0, 1 by 3, this is 3 3 gets cancelled, minus 1 by 5 and 0. If you subtract, what you will get? 1 minus 2 by 5. 1 minus 2 by 5 is 5 minus 2 by 5 is 3 by 5. 3 by 5, 1, this is 0, 0 minus into minus plus 1 by 5 and 0. So these are the elements you are going to get. Now I'll substitute here. So these are the values for R1 dash. I'll substitute in R1 dash. 3 by 5, 1 0, 1 0, 1 by 5, 0. Because these two are gone. Now find out the elements of R3 dash. So R3 dash, for R3 dash, convert this 5 by 3 as a 0. So for this, the operation we are going to use is R3 dash is equal to R3 minus 5 by 3 times R2 dash. That's it. Okay. So using this, what is R3? R3 contains, the elements of R3 are 3 0 5 by 3, 3 0 5 by 3, 3 0 5 by 3, 0 1, 0 comma 1. Okay. Now, and the elements of R2 dash are 6 by 5, 6 by 5, then 0 comma 1, then minus 3 by 5 and 0. So multiply this with 5 by 3. So multiply with 5 by 3. So what you are going to get? So this is same, 3 0 5 by 3, 0 1 as it is, multiply 3 2s are 6 cancel, 5 5 gets cancelled, 3 2s are 6, this is 2, this is 0 5 by 3, 3 3 gets cancelled, minus 1 and 0. Subtract this, 1 0 0 0, you are subtracting 0, minus of minus 1 is plus 1 and 1. So 1 0 1 1 1 is the values we are going to get. Right. I'll substitute here, 1 0 0 1 0 0 1 0 0 1 1. So these are the values I am going to get. Now find out the value of Zj. Zj is equal to multiply, minus 3 2s are 6 by 5, minus 6 by 5, 3 2s are 6 by 5, minus 6 by 5. This is equal to minus 12 by 5 you are going to get here. Next, minus 1 into 0 is 0 and 0, this is minus 1 into 2 is minus 2, remaining are 0. Minus 1 into minus 2 into 0 is 0, minus 1 into 1 is minus 1. This is minus 2 by 5, minus 2 by 5, minus 2 by 5, minus into minus plus 3 by 5, take LCM, 5 is LCM, 3 minus 2 is 1, this is 1 by 5. Again this is 0, 0 and 0, 0. Now find out Zj minus Cj, delta J. Subtract, minus 2 gets cancelled, 0, minus 1 gets cancelled, 1 by 5 minus 0 is 1 by 5, 0. And see here all the values of delta J, that is Zj minus Cj are greater than or equal to 0. This is greater than or equal to 0. Therefore, the optimality is reached. The optimality is reached. So, the optimality is reached and the optimal value is minus 12 by 15 and the values of x1 and x2. x1 is equal to 3 by 5 and x2 is equal to 6 by 5. So, therefore, the x1 value is equal to 3 by 5 and x2 is equal to 6 by 5 and the value of x1 and x2 is 3 by 5 and 6 and the maximum value z maximum is equal to minus 12 by 50, minus 12 by 5. So, z minus 12 divided by 5 is the maximum value. That's it. Hope you followed. So, therefore, the final conclusion is hence the value of x1 is 3 by 5 and x2 is equal to 6 by 5 and the maximum value is minus 12 by 5. So, let us check the maximum value. Since what is given, max z is equal to the equation. What is the equation given? Max z is equal to minus 2x1 minus x2. Minus 2x1 minus 2x1 minus x2. Substitute the values. Minus 2 into x1 is 3 by 5 minus x2 is 6 by 5. This is minus 6 by 5 minus 6 by 5 is equal to minus 12 by 5. So, therefore, z max is equal to minus 12 by 5. So, the maximum value is minus 12 by 5 at x1 is equal to 3 by 5 and x2 is equal to, this is the method, this is how we are going to solve LPP using big M method. Hope you followed this. Now, that's all for today's session. Let us meet with a different concept in the next class. Thank you very much.